Hello friends, welcome to Engineering Funda family. In this video, I am going to explain you PN junction solar cell. Before I start with explanation, let me show you how many things that I am going to cover in this video. So first, I'll be discussing about symbol of solar cell. Then we'll see how characteristics of solar cell is there. After that, I'll explain you basic structure of solar cell. Then I'll explain you how equivalent circuit of solar cell is there, and based on this equivalent circuit, we will be observing few essential parameters of solar cell. And in future coming videos, I'll be solving some interesting questions based on solar cell in which we'll be using those parameters. So let us begin this video with first point, that is symbol of solar cell. If you observe symbol of solar cell, that is two terminal device. Here, see, this is PN junction device, but it is generating power. So instead of diode, here I have shown this as per battery, and this battery is generating power with the use of light. So you can observe incident arrows are there on this battery, which indicates this cell will generate power as if light falls on it. So this positive terminal of battery, that is anode, negative terminal of battery is cathode. This light falls on this battery indicates this is solar cell. That is how basic symbol is there. Now let us try to understand how basic characteristic is there with solar cell. Characteristics of solar cell and characteristics of photodiode both are same. There are few things that you need to understand with photodiode and with solar cell. See, photodiode, that we use it to detect light signal, while solar cell, that we use it to generate power. See, when you use photodiode, at that time you will be keeping photodiode in reverse bias, while when we use solar cell to generate power, at that time here we will be using solar cell in fourth quadrant. So first you need to understand what is happening with photodiode. See, I have told you characteristic of photodiode, that is this, right? If you go through my video based on photodiode, in which I have discussed everything about characteristics of photodiode, so that is this, in which what we have observed was, as if you have intensity of light I1, then in reverse bias we are having higher current compared to dark current. If you further increase intensity of light, then you see reverse bias current will increase, right? And photodiode, that we use it in reverse bias only, that I have told you. So in this third quadrant, we will be using PN junction as photodiode in reverse bias, right? Solar cell, that is also PN junction device, but solar cell, that we use it to generate power, and this solar cell, that we use it in fourth quadrant. Let me show you how. See, as if you keep your PN junction in reverse bias, and as if some light is falling on it, let us consider intensity I1 that is falling on that PN junction. So because of which in reverse bias I1 current is passing. Now if you reduce voltage, right, so in reverse bias current I1 will be there, but if you make your voltage 0 over here, right, across PN junction, then here some current will be there. Let us consider this point as a some current. Now what happens is, if you increase the voltage in forward bias, then what will happen? See, here this current which is happening because of light, now that will get to decrease from here onwards. See, it will decrease like this, and what will happen is, over here, see, it will get, current will get 0, and after that current will increase in forward bias, right? And in forward bias, after some voltage, see, conventional diode current and PN junction under light both will be same, right? So that is how characteristics will be there. Here one thing that you need to understand, see, same thing that you will be using over here as a solar cell. So in fourth quadrant, in this quadrant we will be using that PN junction as a solar cell where we will be generating power. So at this point, what is happening, you see, at this point voltage across PN junction, that is 0, and at that time whatever current is passing through that PN junction, that is short circuit current, so that is referred as ISC current. So at this point current is ISC, and voltage across PN junction, that let us say that is VD, that will be 0. And if you talk about this point, so over here we are having 0 current through diode, and here as current is 0 through PN junction, you can say this is open circuit voltage, so VOC voltage, at which current passing through PN junction, that is ID, which is 0. So these 2 points that explains over here in between this characteristics, there is a generation of power. How much power is getting generated, that even I will be going to derive over here. But first thing that you need to understand, for PN junction photodiode, same characteristic is there with solar cell, but thing is, in this fourth quadrant you will be using same PN junction as a solar cell, while in third quadrant you will be using same PN junction as a photodiode, right? So same structure that you will be using as a photodiode in third quadrant, and in fourth quadrant same structure will generate power. How it will generate power, that we are a little bit to derive. But before that, let me show you basic structure of solar cell. If you observe basic structure of solar cell, then that is PN junction device only. If you observe here, see solar cell structure that I have shown, in which you can observe N-type and P-type layer that is there with us. This is PN junction, and on this PN junction we will fall light, and in solar cell, with the use of this light, we just want to generate electricity. So in photodiode, we just want to identify light signal, while in solar cell, with the use of sunlight, we want to generate power, right? So if you observe structure, there are few basic things that you need to understand. See here at N type, we are having front contact. And those contacts are like this finger contacts. If I show you top view of this front contact, then that will be something like this. Let me draw it over here. That will be something like this. You can observe, right? So that is how front contact will be there, right? And here from front view, you can observe this portion only, right? And in between front contact, there is a gap. Through this gap, light can get entered inside. And see this light that will go to PN junction over here. And once that light goes to PN junction, what happens? Obviously, electron hole pair that will get generated. And as you have electron hole pairs, there will be formation of charge carriers, and those formation of charge carriers will be generating electricity. Like for example, if I say here this light is falling over here, so one electron, let us say this is electron that is getting free, right, at junction. And because of that, what will happen? As if electron is getting free, then it will be generating hole even. Now see what will happen? See this electron that will be moving with respect to electric field which is there at PN junction. So you should know how electric field is there at PN junction. Let me draw it over here. See, as if you talk about electric field, then when junction is created, at that time N-type layer is donating electrons, so it will be forming positive ions. So here there will be positive ions. And this P-type is accepting electrons, so it will be forming negative ions. So what will happen? Because of this positive and negative ions, there will be formation of electric field, and that electric field will be there from positive ions to negative ions. So that is how electric field will be there. Now, because of sunlight, whatever electrons and hole pairs are generated over here, that will be experiencing force. So if you observe, see electric field is there in this direction. So what will happen? As electric field is there in this direction, holes will be moving in the direction of electric field, right? Holes will be moving in the direction of electric field, and electrons will be moving in opposite direction to the direction of electric field. So there will be collection of electrons over here at upper end, and there will be collection of holes at lower end, right? And here we are having front contact and back contact. So here you will at this two terminal, you will be experiencing some voltage, right? And that is what we refer as solar cell. Here this is about working, but if you observe analysis of this structure, then in that there are few basic things that you need to understand. Like you might be having question, why should we have this front contact is like this? It is like finger, right? So for that, see, basic point is shading losses are reduced by decreasing width of finger of the front contact. So see, if you decrease this width, then shading losses, like you see, if sunlight is falling like this, so obviously if metal is there, then there will be shading loss. So as if you want to decrease that shading loss, then all you can do is you can reduce the width of those fingers, right? So that is one point that is very essential. You should keep in that mind. Second point is, you see, anti-reflection coating that we use, and it doesn't allow light energy to go out of the solar cell. Like you see, our agenda is what? Our agenda is to trap sunlight. So as if sunlight goes inside, it should go inside, it should energize electrons so that there will be formation of electron hole pairs, right? So here we are having anti-reflection coating which doesn't allow sun rays to go out of this solar cell, by which you can maximize the efficiency. Third point, if you observe, you see what is written. The width of n-type region is less, as we need to generate more electron hole pairs at p-n junction. Now you will be thinking like, why it is mentioned? You see, here n-type region is there and its width is less. In figure you can observe. Now as this width is less, what happens? Sun rays are coming from here. So obviously junction should be nearer to the side at which we are having sun rays. That's why n-type region that is having less thickness over here, so that junction will be nearer to this energy and there will be formation of electron hole pairs. If this junction that goes somewhere nearer to center or this side, in that case this light energy will have to travel with more distance, which will not allow formation of electron hole pairs, right? So that is third point, that is very interesting and essential. Fourth is, if you observe, light is converted into electrical power using solar cell, and output that we take it in between front contact and back contact, that I have told you, right? This is front contact as per finger shape, and this is back contact. There is nothing like finger shape, right? So, and in between these two terminal, we are taking that solar power, right? So that is how basic structure and working that is there with solar cell. Now I am going to explain you equivalent circuit of solar cell. If you observe equivalent circuit of solar cell, then you see here we are having solar cell across which we are applying voltage VD and current passing through it is ID. Say its equivalent circuit that is having PN junction. So here I have shown diode, you can observe here, and in parallel with diode I have shown current source which generates current IL, and this generation of current IL is there due to sun rays. So if you observe here, see, this is what the structure, right? And in this structure, due to sunlight, we are generating current. So that current is referred IL. So you can say current source in parallel of this PN junction. So PN junction is diode, and in parallel of that, we are having current source. So see, this is how equivalent circuit is there. So this is PN junction diode. In parallel with that, we are having current source. Same thing that I have provided over here as per VD and ID, right? So this is just equivalent circuit of this solar cell. Now here if you observe, see, VD, that is what voltage applied across this solar cell, and ID, that is current given to this solar cell, right? ID. And here if you observe, see, characteristic that I have shown, and that characteristic is there in fourth quadrant only, right? That we have seen. See, in fourth quadrant we are having characteristics. So I have placed it over here, in which, see, as if you talk about short circuit current, right? So why it is short circuit current? The reason is voltage across this is 0 at that instant. So ISC is happening when VD, that is 0. And if you talk about this point, so that is a point at which we are having open circuit voltage. Why? The reason is at this instant current is 0. So you can say ID is 0 over here, right? So VD is equals to VOC when ID is 0, and ID is equals to ISC when VD is 0, right? And I have told you characteristic is happening like this. Characteristic is happening like this, right? That is how characteristic is happening. Now, in this characteristic, let me explain you first how we can identify value of ISC and VOC. After that, I'll explain you few essential parameters of solar cell. So here, see, if you observe this equivalent circuit, so in this equivalent circuit, see, if you apply Kirchhoff current law at this node, then entering current is equals to leaving current. So as per KVL, let us say this is node A. So at node A, apply Kirchhoff current law, KCL. So if you apply KCL here, then entering current is IL plus ID. So IL plus ID, that is entering current, and leaving current. So see, current passing through diode, that you should know, it is how much? I naught into e to the power VD by VT minus 1. Right? This is standard equation for current passing through PN junction. So that is I naught into e to the power VD by VT minus 1. See, this is how basic current equation that we have it for this equivalent circuit. Now, as I have told you, if you want to measure ISC, means short circuit current, see, this characteristic is for solar cell only, right? So in fourth quadrant only, we need to observe how characteristic is there. The reason is in that quadrant only, we are operating that PN junction as solar cell, right? So if you want to calculate what is ISC, so if you want to calculate what is ISC, so for ISC, you will be having ISC is equals to ID provided VD is 0. Provided VD is 0, right? So just apply this in this equation and let us see what is our answer. So ISC is ID. So IL plus ID is ISC now. That is equals to I naught into, you see, e to the power VD. So e to the power 0 is there, minus 1. E to the power 0 is 1. 1 minus 1, this is 0. So you can say this term is getting cancelled. 1 minus 1, 0. So what is ISC now? ISC, now that is minus of IL. What is IL? IL is current due to light. IL is current due to light. You see, that is a current source that you can say. So here, short circuit current ISC in this characteristic, that is minus IL, right? But here we are just considering this characteristic like this. Otherwise, with respect to direction only, we need to consider all those things, right? So that is how we are having short circuit current. Now, if you want to calculate what is VOC, so for VOC calculation, what we need to do? For VOC, see what is VOC? VOC is VD. VOC is VD. VOC is VD provided ID is 0. Provided ID is 0. So just apply this in this equation, right? So what will happen? You see, VOC is VD provided ID is 0. So IL is there with us. So here IL, ID is 0. So I am keeping this 0. That is equals to I naught into e to the power VD. So VD is VOC divided by VT minus 1. See, this is how it is there. Now just simplify this. So if you simplify this, see what will happen. Just take this in denominator and this 1 will go on other side. So it will be plus 1. So e to the power VOC by VT, that is equals to IL by I naught plus 1. And if you take natural log at both of the side, then see this will become VOC is equals to VT ln of IL by I naught plus 1. So that is how we can have these two equations, and these are very essential equations for solving questions. You should know this, right? So let me keep it in box. The reason is we'll be using it, right? So ISC is current due to light and VOC is VT into ln IL by I naught plus 1, right? That is how we can derive this, right? Now I'm going to explain you few essential parameters that even will be using it for solution of questions. So let us derive those essential parameters. So here in parameters, I'll be deriving two parameters of solar cell. One is fill factor and second is efficiency. So before I derive, again I'll be repeating these characteristics. The reason is that characteristics that should be in your brain to understand how solar cell functions, right? So as I have told you, we use solar cell in fourth quadrant. Here with current, we are having ISC current at which we are having VD is equals to 0, and at this point we are having VOC voltage at which we are having ID current is equals to 0. And if you observe, characteristic will be like this, right? Characteristic will be like this. So see, for solar cell operation, that operating point that should be somewhere in between this line, right? Somewhere in between this line. Now how we are generating power? For that, let me consider one example here. So for that, if I say this is the point at which we are operating with solar cell. So at this point, if you want to calculate what is the power, then that power will be this area. That power will be this area, right? So if you talk about this point, power will be this area. So obviously we want to operate solar cell at a point at which maximum power is getting generated. So as if you want to generate maximum power, then you will have to observe at which point maximum area is covered, right? So at this point area is this much. Now obviously if you talk about maximum area, then that maximum area will be there at which point? It will be there somewhere over here where you will be having maximum area, you see, right? So that is how maximum area that you can have, which explains this is a point at which maximum power is generated by solar cell. So maximum power that will be generated at this point, right? Now at this point, as if power is maximum, then you can say here voltage is maximum and current is maximum, right? At this point, voltage and current both are maximum, then only you can say power is maximum over here. So I'm just keeping notation as per Vm and In, at which point we are having maximum power generation. Now let us try to understand what is fill factor. So let me note down that fill factor. So what is fill factor? See, fill factor is maximum power generated. So maximum power generated is how much? That is Vm by Im divided by total area. So what is total area? You see, that is that much. Total area is how much? You see, that is that much, right? Total area is this much with respect to VOC and ISC. So fill factor is how much? Fill factor is maximum power divided by total maximum area. So total maximum area, that is VOC into ISC, VOC into ISC. So fill factor, that is VMIM divided by VOC ISC, and from this you can directly say it is always less than 1, right? It is always less than 1. Why? The reason is obviously VOC into ISC, that is quite higher as per area, you can directly observe. So fill factor explains that only, like how much area that we fill out of this total area, right? Now second is efficiency. Let me note down that efficiency. So efficiency, that is how much? You see, efficiency is amount of power generated divided by total power of light. See, it is amount of maximum power generated by solar cell divided by total power of light fall on that solar cell, right? So here you see on this solar cell, this light is having some power. So that is P in. And how much maximum power that is generated? So that I have told you, that will be at this point, which will be VMIM. See, human can control this VMIM, operating point of solar cell, but human cannot control how much energy that will be given by solar, right? So efficiency will be how much? It will be maximum operating point power, that is VMIM divided by P in. This P in is power input by sun rays, right? Now if you wanted to have this in form of fill factor, then VMIM, that you can substitute as per fill factor. So fill factor into VOC ISC, that is VMIM divided by P in. And we'll be going to use these formulas, right, for solution of problems. So you should keep this formula in your mind. Definitely that will be helpful to you in GATE examination, in UPSC examination, in ISRO examination as well. So in future coming videos, I'll be solving some interesting questions that will definitely make sure to have proper calculation of questions using this formula. I hope it is clear to you still. If anything that I would like to share, please note it down in the comment section. I'll be happy to help you. Thank you so much for watching this video.